In this video, I am going to discuss about domain of the function using shortcuts. Before going that, so we will discuss about first what is the meaning of domain. So in this case, so let f from a tends to b be a function defined by f of x is equal to y, or y is equal to f of x. In this case, a is the domain of that function, domain of this function. So this function can be represented in picture. So this is domain, this is codomain. So in this case, range are there. So f be the function from a tends to b. So a is the domain. In this domain, elements is in the form of x. So x is the domain. So we have to find out the x value, that is the domain. In these points, the function is defined. So put input value x, we get the output value y, that is equal to f of x. This is range. After the discussion of domain, we will discuss about range. So first we have to discuss about domain. So this is codomain. This is domain. Function is in the form of f of x is equal to y. In this case, x is the domain. So set of all x elements is called domain of the given function. So now we take some examples, standard examples, and discuss about domain. So first in this case, let y is equal to or nothing but f of x is equal to x plus 1 is one function, comma g of x. So another log function, this is base e, it is understood, log of x plus 1, and one more function we take h of x is, it contains square root of x plus 1 into 1 minus x. So these are the functions, be the functions. So we have to find out the domain of these functions. In this case, we take f of x first. F of x is equal to x plus 1. It is polynomial function. So polynomial functions are everywhere defined. So it is domain of the polynomial function is everywhere nothing but real number. So domain of polynomial function must and should be real number set. Domain of f of x is d of f of x, nothing but domain of f is equal to real number, nothing but minus infinity to plus infinity. And next, so discuss about g of x, domain of g of x. G of x is in the form of, in this case, log of x plus 1. So function, log function defined when, so input value must and should be strictly greater than 0. So using this condition, we have to find out the domain of for log function. Here in this case, domain means what? X value. So using the formula in this type, domain of g in this case, nothing but log of f of x, h of x, or here f of x is there. Domain of g of x is equal to g of, in this case, g of x, nothing but here log of f of x is there. So not doubt x such that x belongs to any real number, So domain is in the, here g of x is in the form of what? So is in the form of g of x is in the form of log of another function f of x is there. So here f of x is x plus 1, whatever it may be. So here we have to find out domain of g of x is in the form of x, no doubt elements x, such that x belongs to any real number, and here f of x is strictly greater than 0. This is the domain of any log function. Using this formula, we have to find out the domain of any log functions. So in this case, we have to find out domain using this condition. So f of x is greater than 0. Here in this case, f of x is what? X plus 1. So f of x is equal to x plus 1. So find the x values, note out real number if f of x is greater than 0. So greater than 0. Greater than 0, nothing but what in this case? X greater than minus 1. So x is strictly greater than minus 1. Nothing but what? X belongs to open interval minus 1 to plus infinity is the domain of the g of function in this case. So first we have to find out in this case domain is what? F of x. What is the f of x domain? Domain of f is equal to a real number, nothing but minus infinity to plus infinity. And next we have to find out the domain of log function. So in this case, domain of log function means what? G of x is equal to open interval minus 1 to plus infinity. And next we have to find out the domain of h of x. So here square root is there. Very careful about this type of function. So in this type of function, in the root, minus is not there. So if minus is there, the function is not defined. So using this condition, we have to identify the domain of these type of functions. So let us take a third. So h of x is equal to square root of x plus 1 into 1 minus x is there. So this is in the form of h of x is equal to square root of, this can be written as capital H of x. So these type of functions, we have to find out the domain of these type of functions by using this condition. So h of x domain is equal to no doubt x values such that x belongs to any real number. So this is in the form of this is, okay, if h of x is this type, then domain is in this type. Domain h of x is equal to set of all x elements such that x belongs to real number, and the condition is there in this case, no negative values are there in the square root, because the function is not defined, function is dead. So in this case, h of x must and should be greater than or equal to 0. So in h of x is greater than or equal to 0, we have to find out the x value. These x values are the domain of h of x, because in h of x strictly less than 0, this becomes negative. Square root of negative becomes what? Complex number. So hence function is not defined at h of x is strictly less than 0. So function is defined when h of x is greater than or equal to 0. So we have to find out the using domain using the condition h of x is greater than or equal to 0. Any functions is in the form, we have to find out the domain using this formula or this shortcut. So in this case, h of x is what? X plus 1 into 1 minus x. So x plus 1 into 1 minus x. This function is defined if x plus 1 into 1 minus x greater than or equal to 0. Then find the x values. This is the domain of this function. So x plus 1 into 1 minus x is there. So here in this case, our convenient multiply by minus 1 on both sides. Linear inequation less than, greater than or equal becomes less than or equal. So x plus 1 can be written as x minus of minus 1. Here minus is multiplied on both sides, nothing but it becomes x minus 1. So greater than or equal becomes less than or equal 0. So this is in the form of x minus alpha into x minus beta less than or equal to 0. This implies x greater than or equal to alpha less than or equal to beta. In this case alpha is less than beta. Using this linear inequation formula, so directly we can write x values. So what is the x values in this case? X belongs to the open closed interval, nothing but it is what? Closed interval alpha to beta. So including minus 1 to plus 1. So domain of this function is closed interval minus 1 comma plus 1. So here in this case 3, domain of h of x is equal to, what is that? Closed interval minus 1 to plus 1. So we have to find out the domain of polynomial function. One example we take one example, and domain of log function, one example we take. So domain of square root function. So all are find out by using a shortcut method. Take down. Now we will discuss about the algebra and domain of the function. So in this case we take 3 examples. One is polynomial function, second one is logarithm function, third one is square root. So in this case we can use these 3 functions. Addition of any 2 functions, what is the domain? Subtraction of any 2 functions, what is the domain? Multiplication of any 2 functions, what is the domain? Division of any 2 functions, what is the domain? We will discuss about algebra and domain of the function. So first we take in this case addition or subtraction. So domain of, let f and g be the any 2 functions, f plus or minus g. Domain of f plus or minus g equal to domain of f intersection domain of g. So in the both case, so domain of f plus or minus g equal to domain of f intersection domain of g. Using this shortcut we have to identify the addition or subtraction of any 2 function domain. So let us we take examples, these 2 examples. In this case we take one is polynomial, another one is logarithm, whatever it may be. So in this case, so domain of fg. So example, in the above example, domain of f plus or minus g, nothing but what in this case? X plus 1, f of x plus 1, intersection domain of g of x, in this case log of x plus 1, log of x plus 1. So in this case domain of x plus 1 is what? Entire real number, nothing but minus infinity to plus infinity. Intersection domain of log of x plus 1 is what? In this case minus 1 to plus infinity, open interval, minus 1 to plus infinity. So this is the subset of this. So we know that if A is subset of B, then A intersection B is equal to A. Using this formula, set formula, we have to find out the intersection. So this is the subset of this. So answer of this question is open interval minus 1 to plus infinity. So directly we can write domain of f plus or minus, either plus or minus, is equal to what? Minus 1 to open interval minus 1 to plus infinity. So I easily identify the domain of addition or subtraction of any 2 functions. Next we take multiplication, second one. Domain of f into g is equal to, here also same formula, domain of f intersection domain of g. So same functions we take examples. So domain of f into g, nothing but in this case domain of x plus 1 into, here in nothing but intersection, domain of g is what? Domain of log of x plus 1. So same we can write domain of x plus 1 is minus infinity to plus infinity, intersection domain of log of x plus 1, nothing but what? Minus 1 to infinity. So using the formula set, so intersection, this is the subset of this. So answer of this question is minus 1 to plus infinity here also. So easily identify the product of two functions. So product nothing but what, in this case f into g nothing but x plus 1 into log of x plus 1. So x plus 1 into log of x plus 1, f into g. F into g is what in this case? F into g nothing but x plus 1 into log of x plus 1. So domain of this function is minus 1 to plus infinity. Here also addition is there, or subtraction. F g nothing but what? F plus or minus g nothing but x plus 1 plus or minus log of x plus 1. So both are same in this case. So now we take next question number 3, nothing but in this case division. So division nothing but what? We take domain of h divided by f. Division is there in this case. Nothing but domain of h intersection domain of f, no doubt. So subtracted by these elements. So here f is not equal to 0 in this case because function is not defined. So we have to find out the x values such that no doubt x belongs to real number. In this case f of x is not equal to, here 0, equal to 0 in this case. So equal to 0. F of x is equal to 0. What elements we have to find out? X. These x points subtracted by this set, we get the domain of the h by f. So using same rule, so we have to find out the values of domain of h by x. Same value. H is this is function, f is this function. So in this case domain of h by f nothing but domain of square root of x plus 1 into x minus 1 minus x, 1 minus x divided by f nothing but x plus 1. So no doubt intersection domain of h, domain of f nothing but what? So this is h nothing but minus 1 to plus 1, closed interval minus 1 to plus 1. Intersection domain of f is entire real number minus infinity to plus infinity. These elements subtracted by the f of x is equal to 0. We have to find out x values if f of x is equal to 0. F of x is equal to 0 means what? Put x is equal to minus 1, f of x is equal to 0. Only one point is obtained. So that is set contains minus 1. So f here in this case domain of h rational function h by f is equal to, so this is the minus 1 to plus 1 closed interval intersection minus infinity to plus infinity. It is the subset of this. So we get minus 1 to plus 1, both are included, but minus 1 is not there. It becomes open, semi-open, minus 1, semi-closed, plus 1. This is the domain of the rational function h by f in this case. Take down. Now let us move on to the domain of composite function, fourth one. So here we take example, let f from real number tends to 0 to infinity be a function defined by f of x is equal to e power x, exponential function, and similarly g from 0 to infinity, input value positive, output value real number. Function, it is also a function defined by logarithm function. This is g of x is equal to log x base c. So now we have to find out the composition of functions. Here in this case composition g, composition f is composed in g only because codomain of f is equal to the domain of g. So hence gf is composed in g. So in this case this implies g composition f is equal to, so g of f of x is equal to g of f of x, nothing but in this case e power x. So e of x, x in the g of x replaced with e of x, e power x, it becomes log e power x is equal to what? X. So identity function this is. So identity function, domain of this identity function is what? G composition f, no doubt real number, already well known about domain of G composition f is real number. So it is equal to domain of what? F. So domain of f, this is the formula. So conclude that, so in generally domain of G composition, let f and g be the any two functions, in generally domain of G composition f is equal to domain of f, or domain of f composition G is there, it becomes domain of G. When f composition and G composition are defined, so domain of G composition f is equal to domain of f, domain of f composition G is equal to domain of G. In this way directly we can write domain of G composition f is domain of f equal to what? Real number. We cannot calculate this value in this case using this formula. Okay, take down.